filing in, I'd like to welcome you all to this panel on managing virtual power plants of the future. And my name is Alta Colo. I'm the research manager for the Grid Edge research team. And today I have a worldly panel with me to discuss what the virtual power plant of the future entails. So before we get into it, I'd like to remind you all to log into gtm.cnf.io and ask all of your questions. I'll be looking at those throughout the session and ask towards the end. And of course, those of you watching live can also ask questions as well, and please vote up your favorite questions so I know where to go to. So up here I have with me Phil Blythe, the CEO and founder of GreenSync, Jan-Willem Rombouts, the co-founder of Restore, part of Centrica Business Solutions, and Bud Vos, president and CEO of Enbala Power Networks. So these folks are coming from around the world, and as technology providers, they're orchestrating distributed energy resources. And I'm going to go off of what Ben said this morning, that there is an opportunity presented with the orchestration of distributed energy resources, and these are the guys that are making this happen for utilities. So I'm going to ask each of them to introduce themselves and the technology solution they provide to utilities to bring this opportunity of distributed energy resources to light. So I'm going to start with the farthest distance traveled, all the way on that end. So let us know what part of the world you're coming from and your solution.
Great, thanks, Elta. So yeah, look, I'm here from Melbourne, Australia. GreenSync's a company that's been in distributed energy since 2010. We've done a whole host of programs. We're a software company. We sell software to utilities. But we've been through, I guess, the journey, which likewise my peers here have done in other jurisdictions around the world. We started in the non-wires space, in non-network solutions space. It was now called DERMS. We have done virtual power plants in the hundreds of megawatts and still scaling towards a gigawatt with major retailers in the wholesale markets in Australia. We've done microgrids. We've taken entire streets offline and isolated streets purely on solar and storage. And now we're getting into virtual power plants with residential battery storages in the thousands. Australia's an interesting landscape. It's got some real issues. We've had energy security problems. We have some of the highest density of DERs per capita in Australia. And the latest move really in the migration of the energy market is towards the DSO and the DMO, the distributed system operator and distributed decentralized markets. So that's the latest sort of technology where we've come from. So GreenSync, we're the largest player in Australia. We're now sort of expanding globally, and yeah, I'm keen to share some thoughts on that with the panel today.
Great, Jan-Willem.
Yep, so Jan-Willem Rombouts, co-founder of Restore, now part of Centrica Business Solutions. At Centrica Business Solutions, we offer holistic energy solutions to commercial and industrial consumers. This means that we can essentially address any need that they have on the energy side, whether it's need for CHPs, storage, solar, or a combination of those. And a big part of that is as well optimization capabilities. So actually monetizing the flexible power that is present either in the industrial processes of industrial players, cooling at commercial facilities, and monetizing that in the market. And so that is the business that we built at Restore before we were acquired and are now scaling across the globe. And our, I would say, USP is really multi-asset, multi-market, in the sense that we aggregate any group of distributed energy resources, whether micro-production or load or storage, and then put it into all of the markets where it can make money. So that's on the grid side, from frequency regulation down to capacity markets, but also for energy bill reduction, whether it's managing coincidence peaks, demand charges, or anything else that can help the customer reduce the energy bill.
Great, Bud?
Great, thank you very much, and thanks for having Enbala here again, back, I think, what, third or fourth year in a row. So thank you, and it's a pleasure to see many friendly faces here, although I can't see anybody because of these lights. But So Imbala, many of you know the company and have heard the company here from a North American context. And we've been doing many of the things that both Jan and Phil have spoken about, largely around aggregating both loads and batteries and all types of resources into both virtual power plants as well as DERMS applications for electric utilities. I think what makes Imbala very unique is that we started from the world of frequency regulation, some of the hardest, most complex challenges in the marketplace, and delivering software to do very, very fast system optimization to be able to deliver into those types of grid services. We've continued to expand our product offering with virtual power plants and now DERMS applications, doing everything from controlling assets for capacity or energy markets all the way into controlling things on a distribution feeder to manage individual voltage or reactive type characteristics within that feeder. Many partners here in North America and starting to grow a bit more globally as well. So thank you.
Great. Thanks all. So I'm going to address this kind of off the bat, right? So our title of this panel is Managing the VPP of the Future, but I think in some pockets, this is the VPP of the present. So I'd actually like to get an idea of what you guys define a VPP, right? Because we got North America, we got Europe, we got Australia, 3 continents over here. So how are you guys approaching the VPP? Bud, let's start with you this time.
Yeah, great. So first of all, I want to give a huge accolade to GTM because I think you successfully used every acronym possible in the title of this session. And unfortunately, VPP, microgrid, DER, and DERMS are all terms that are being thrown about. And I'll give you the way that Imbala looks at this and kind of and where we're finding traction here, mostly North America-wise. The customers that we're delivering our virtual power plant solution to, first of all, they're largely looking at aggregating large networks of distributed energy resources, behind the meter loads, behind the meter battery, making it all work together. But they're usually using it for what we call system-wide benefits, and those could also be market-side benefits. So you're essentially delivering it like you would deliver a capacity product, and a lot of our customers think of this as kind of DR++. So kind of the next generation of real-time demand response, multi-asset for sure, as Jan described, and being able to kind of go that next step beyond just traditional demand response or load drop. The challenge for a lot of these customers in North America is how do they bridge that gap from demand response to a VPP and then to DERMS? And what is the DERMS piece? And so in our world, we think of the DERMS component as when you start taking that VPP and you now start breaking it down and doing something local at the substation level or at the feeder level. Some of the optimizations are actually very similar, and you solve many of the same power system type problems, but you're now doing it at a much more granular level at a distribution feeder or an individual circuit. And so that is the challenge we have in this industry, and one thing that I think Imbala has tried to step out and try and help is clarify like all these different terms, because everybody's using them, but nobody's crisply defined, what is a virtual power plant, what is a DERMS system, what makes them different, what makes them similar. And that's what we're seeing here in North America.
And just a quick follow-up to that, do you think that's partly market specific?
Yeah, great question, and I think it'll dovetail to my colleagues here on the panel, because in Europe, for example, what we see as a virtual power plant is typically not being used for the same things that people buy a virtual power plant for here. You have a largely unregulated market, so you have things that are being used for energy markets. I'm sure Phil can touch on the dynamics in the Australian market and what makes that very different with the gentailer type market. So that adds a layer of complexity around what is the value prop and ultimately to the customer and the utility, and ultimately how are they monetizing these assets or actually utilizing them.
Jan, Willem?
Yeah, so all interesting acronyms indeed. When I first heard DERMS, I thought it was some kind of skin disease.
Hey, that's my line. I've used that line for
Is that right?
years. Yeah, absolutely.
So virtual power plants.
It is a skin disease, by the way.
The way we look at it is you have a lot of idle resources sitting at the edge of the grid, and so you have some storage units that are being used to store solar. You have electric boilers in households. You have industrial machines, heavy industry. You have all kinds of assets that could use, or that could be used rather in the grid to perform interesting services. And so for grid operators, as you have the higher penetration of renewable energy, they're faced with real challenges, and those challenges go from very local issues in the grid at the distribution system with voltage control, congestion management, and all such challenges, to kind of ISO challenges being frequency regulation, spinning reserves, et cetera, et cetera. And so to us, the VPP construct is really to bridge those two things. On the one hand, you have very concrete challenges for grid operators at all those levels. On the other hand, you have all of these kind of idle resources sitting. In order to make those idle resources into something useful to actually address those challenges, you need smart software and connectivity. And so the role of an aggregator in that context, making these VPPs, or the role of that software, is really to tune these resources once they're grouped so that they can really address exactly those issues in the grid that are most challenging. And that to us is the essential meaning of a VPP construct.
Great. Phil?
Yeah, look, I think there's a few different dimensions to this nomenclature that we use across the industry, and certainly, generally the way I would agree with Bud that we tend to think of VPPs as the actor, being someone who wants to monetize it across the system. So that could be an ISO, it could be a retailer in different markets, but trying to work out from a wholesale market perspective, whereas a DERMS platform comes from, say, a distribution network wants to optimize locally on their electrical system, and so much more in touch with the physics. I guess that it gets compounded when we have aggregators, because then aggregators are combining both and trying to do that joint optimization. So I think even across this panel you start to get a lack of uniformity across that. But I think there's another concept that's going to start to just as we define what these things are, I think it's going to move again. And I'll tell you why I think that. In Australia, as you get to higher and higher density of distributed resources, VPPs become almost like silos. You build a silo of a system that works for a certain set of resources, and they're stuck in that silo. And then another network builds another silo. And so if you actually need to get efficiency and value stack the value propositions across a resource, it soon becomes really cumbersome and unwieldy. Mm-hmm. So I think we need to evolve to a point where we're all going to be representing different actors in a system, and it takes place in a market construct. So I think we've got to, the concepts and the nomenclature has to evolve with the technology.
Yeah, so I'm going to bounce off of that, right? So, we've spoken a bit about the work that you're doing in Australia and kind of enabling that distribution market. Can you just tell us a little bit more about that?
Sure. So the concept of the distribution system operator is really and the market operator is the idea that DERs need to value stack and have many different proponents that can essentially contract a single asset. And essentially, as a contracting market, there's a consortium that was put together a couple of years ago called DEX that we created with a number of other utilities. Started as 8 members in a consortium, it's now 75. And it's a consortium of network operators, retailers, the system operators, the regulators, and a lot of now technology vendors who play directly into the market. And the idea that it's a collaboration, everyone plays a role within that collaboration, and we start to define things like there's a central exchange, and then there's various actors providing different value streams towards the distributed resources. So that's essentially been the emergence of that model. It's now moving into pilots in 2 states, and we'll be rolling out across Australia over the next 2 to 3 years. Now that's Australia. We have burning platforms to do that. We have minimum demand issues, surplus energy. We have energy security challenges from the lack of synchronous generation. So there is a real reason for Australia to move quickly towards this model. We're starting to see it emerge in the UK, and the debate's starting to high up there, obviously in the northeast corner with the REV as well. Yep. But it's driven really by need, and I think that's the important thing to understand is that markets have different needs and therefore start to move and adopt different models.
Yeah, that's great. Just, to move on here a little bit, Jan-Willem, we've talked a little bit about architecture and kind of where this intelligence should lie. Can you just expand a little bit on that?
Yeah, so it's as such, if you want to build this kind of VPP that can serve local needs in the grid as well as kind of global ISO level needs. You're going to need kind of a centralized intelligence that can do portfolio management, if you want, of these distributed energy resources. But if it's just centralized, you're not going to get there because you're not going to have the kind of speed of response that is required. And so there needs to be at least some intelligence that is living at the edge of the grid. And so we really carefully try to balance that with hybrid architectures where you have the cloud really monitoring the state of these resources very carefully, doing optimization at a kind of centralized level, saying maybe it's better to group a set of resources there to provide that services locally and group these resources as a whole to then provide something at the ISO level. But at the same time, there's local intelligence so that, for instance, in the case of frequency deviations, once there is a frequency deviation, everything acts fully autonomously. And so really balancing that kind of edge computing with cloud intelligence is key to building really useful VPPs in the grid today.
Yeah. But I know you recently had an announcement earlier this year about how you guys are plugging into a microgrid. And can you tell us about how kind of your secret sauce there is enabling that kind of seamless disconnection and optimization?
Yeah, absolutely. First of all, I'll echo the comments here about the architecture component. I think a hybrid decentralized architecture is absolutely needed in this world. And as a result of that, one of the key components that we focus on is the ability to incorporate this multi-asset, multi-service architecture so that we can seamlessly bring all types of assets into that and they can actually begin to play and work together. So the microgrid that you're referring to is some work that we've done up in Ontario, focused on bringing in fleets of electric vehicles, CHP, solar, traditional battery storage, all in a complete cohesive set that is then collectively responding to different grid signals and grid service signals coming from the ISO. Here we have a very unique opportunity because we have a traditional utility that is delivering these services out to their customers, believes in the growth of electric vehicles and believes in the growth of behind-the-meter energy storage. And you have a market in Ontario that is actually very willing to let those assets participate. The challenge is, again, how do you make the small look like the very large? And how do you bring those all together, both seamlessly at the customer level or at the asset level, but yet deliver a very reliable grid service looking like a traditional generator on the system? Mm-hmm. And that's really the core of our technology, and the speed of optimization and all of those concepts allow us to be able to do that.
Great.
And again, we now got to buzzword 4, microgrid. We snuck microgrid in there, so
yeah.
Good job.
So I think we hit them all, right? So, while we're at this, Jan Willem, I know you guys recently announced a project with in Terhills in Belgium, right? And can you tell us a little bit about kind of the value stacking opportunity that there's there? I know we've touched upon it a little bit, but
yeah, perhaps a good point to start is actually the customer and the customer experience, because we haven't mentioned much about the customer so far in the discussion.
It's not up on the list.
Yeah, it's not on the list. But ultimately, it's about how can you provide a valuable service to the customer? How can you achieve a good business case for investors, for instance, of batteries? How can you create that great customer experience? And so value stacking is one of the ways in which you can really optimize the revenue for the customer. The way we did that in Terhills, this was a project that consisted out of an 18 megawatt battery in front of the meter battery, 22 megawatt hours of energy. And we combined that battery in a virtual power plant where we added all kinds of other resources that were distributed across, this was in Belgium, across the ISO region. And it included CHPs, it included industrial loads, all types of assets. And actually by combining that and then putting this virtual power plant in the frequency regulation market, we could realize up to 50% more revenue on this battery. So just from combining distributed energy resources in a pool, you can actually make more money on them, which is then interesting for the customer ultimately. But so that's kind of synthetic pooling, as we call it. But then next to that, we didn't put that VPP just in the frequency regulation market, but we also started to stack value. And so one of the things is real-time energy arbitrage. Actually, so we nominate that, or we bid that VPP into the day-ahead markets every day, and then we play on the real-time energy market. And that adds yet another value stack to the end customer, which makes the business case even better. So that was our approach. So kind of synthetic pooling, and next to that, doing the maximum of value stacking possible, ultimately leads to the most efficient solution and the best proposition for the customer.
Great. I'm going to transition a little bit here. You know, you guys are all technology providers, but I'm sure when you got into this game, you probably weren't thinking policy and regulation would be just as big of a part of what you do in order to bring your solution to market. And with that, obviously, I think my understanding is that the full breadth of the capabilities that you have is not being utilized, right? So how are you involved in this regulatory process and market design process? I think Phil is inching to start.
Yeah, I'm going to start with that one because I actually think that's really, I think that's the guts of it. I think, you know, I think all of the technology companies, like all of us here today, we know how to do this, but the problem is scale and productionizing the energy environment so that this becomes really easy. And you mentioned that project, and I heard about yours, Bud, and I know what some of those projects we've done. They're just, it's like pulling teeth. It's so hard to do, right? And you break down the walls thinking, right, now I've broken those down, it's going to be much easier next time I do it. But of course, you go to another utility and you have the same problems all over again. So I think if we're going to do it systematically, all of us were going to get a scaled outcome where distributed resources integrate seamlessly. We've got to bring the cost of these projects down. It's got to be seamless and it's got to scale. And that comes from the working closely with the regulators to ensure that we basically, I think we invent technologies that overcome some of these barriers for the networks and for the utilities. But I think regulators need to be comfortable with sitting alongside technology companies as we move into these new spaces and not regulate ahead of us, but work with us and understand if there's we're delivering more value to customers, absolutely we should continue to do so, and only regulate when regulation is necessary. And that relationship, I think, is probably the best thing that this industry can do is you know, have that very collaborative relationship with regulators.
I think the technology is always a little bit ahead of things. And honestly, if you speak to ISOs in the States, and they look at that VPP construct, for instance, and value stacking, they say, well, in principle, that's great, and we need that, and we want that. But the regulation is always a little bit behind. And so ultimately, if you want to create liquidity, creating a lot of flexible power in the system that can be utilized to facilitate renewable energy, then you're going to need regulation that allows that. And so very concretely today, value stacking is not very well designed in most markets. In California, they are just starting CPUC, a very good initiative to look at this. But you need the market rules that tell you, well, you can stack A and B, but not A and C, before you can actually start offering those services to customers. And so if you don't have that in place, if you can't build synthetic virtual power plants, which you cannot do today in California, actually, for all the markets, then you're limited. And that means that, you know, the business case for the battery will look worse. Then the proposition that you make to an industrial will look worse, and it will slow things down.
Yeah, I hate to make it sound like a love fest up here, but because the technology sounds similar and a lot of the stories all sound similar in terms of where value is coming from, but I think what's key is that these are pockets. These are pockets of where people have been able to work this out and sort through it, as Phil said. And this concept of value stacking, which is, you know, a concept that you know, we started talking about almost 8 years ago, it still is really hard for 80%, I would say, of the market to truly understand how can I go get my rate of recovery or my value prop or my monetization across a suite of services. And so I think, again, here in North America, what we continue to see is utilities who have got tried and true demand response business models, which is essentially one value stream, and they are layering on top of that. So I would continue to challenge the status quo with our utility partners and our regulators to say these assets can be used for much more than one value stream of a demand response or capacity value stream. We have to start figuring that out, both at the regulatory level as well as at the kind of utility executive level. We have to figure out how to make it okay for utility to go do those things.
But you know what? I think it's also it's a mental state. And I've just been in the States for the last week. We talked about value stacking. I described how the fact that we could have one value stream and another, and if there was a dispatch call simultaneously, you get paid twice. And there was this look of horror on his face. And I think that's where it sort of comes from. I think there's this construct that people are basically going outside of the regulations and are essentially not justified for getting paid from value stacking. So I actually would push a little bit further than saying we don't need a set of rules necessarily from the regulators. I think we need to change the mindset by actually enabling the technology and showcasing that technology more broadly to distribution networks, to ISOs, and say we can value stack, and it actually is a legitimate way to do it, and bring the regulators in on that journey and just actually move forward. I actually think in many parts this is uncharted territory. There are no regulations on exactly how this should work, and I think technology providers can play a really strong leadership role in pushing that forward.
I think we need to be sensitive as well, in the sense that we don't want to go out as a bunch of cowboys. You know, we don't care about the regulations. But for instance, if you're using an asset for congestion management or like non-wire alternatives, and it's really critical to maintain the stability of the grid at a local level. Then bidding that same asset for the same capacity into frequency regulation or into a market that is critical to maintain stability at the TSO, that's not reasonable, right? And so I think the point is to work together very closely with ISOs and regulators and to do what is sensible. But what is there now is essentially nothing in a lot of markets, and that's not good enough.
Yeah.
Great. Well, I'm going to ask the most burning question that's popped up here from our audience. Are any of you aware of a viable locational value tool for distributed energy resources? A locational value tool for distributed energy resources.
I'll start, but look, I mean, I think the idea of locational price signaling, it's certainly in the New York Rev design, that's certainly part of the design of DEX in Australia, is to allow locational price signals all the way down to a street level, down to a sort of low voltage feeder level. Look, it's a bit of a utopia, but I think we need to start moving the system towards that design. Are there systems emerging that can handle this type of pricing regime? Starting to, I would say. That's an endeavour. But over the next 3 years, I think we'll start to see that start to be sewn into the fabric of the system design.
Yeah.
All right. Well, you know, we got about 2 minutes left, and kind of my burning question is, because you guys are coming to me around the world, why are we all in California today in the U.S. market? What is the opportunity that you're all seeing here for your customers or potential customers?
Would you like me to start?
Yeah.
So, I mean, I think the opportunity here in North America, like I said, is still very localized in a sense. It's regionalized. There are a number of states that are stepping out, a number of utilities that are stepping out, and I think there are many of those that are trying to understand this progression from, you know, demand response to virtual power plants to DERMS. And though there are pockets around doing that, they typically coincide with areas where there are high penetration renewables and other things that are actually driving either grid needs or local capacity type needs. But it is not universal. I want to be very clear about that. There are parts of the United States that are going to show up third or fourth in terms of figuring that out. So here in North America, I mean, I would say that's where the pockets are, and certainly California is one of those, which is, you know, obviously why we are all sitting here today in the great state of California.
Great.
Yeah, for Centrica Business Solutions, I think the opportunity is in that a lot of C&I customers have serious needs on the energy front. And we're able to offer really holistic solution, as I mentioned earlier, providing for all of the, or addressing all of the needs that customers have. And so that is one thing, but next to that, you also have a system that is in pain a little bit. And that typically is good news for the people on the panel here, in that there is a need for solutions for the grid operators as well. And so California still has quite a bit of challenges with the duck curve, with congestion issues, et cetera. Markets are being structured around that quite slowly, but fundamentally there's a lot of value. And then ultimately you move to a system where distributed energy resources are facilitating renewable energy and the end customer experience improves. And that's a good end state.
Phil?
Yeah, I would agree with Jan. I think California is starting to show the signs of a congested market with DERs, that 20% on rooftops, the rule changes on building codes to see solar on every rooftop. That's clearly a sign that these problems are going to start to emerge, and that's the best reason for us to be in a geography, right? Because the market needs to change, and in this case, the regulators are favourable to pushing that transition. So they're all the ingredients that we all need to see a substantive change.
Great. Well, that's all the time we have today, so please find our panelists to continue the conversations.